Okay, we should be live. Let me check a couple of things. Just share it quickly. On Twitter. And LinkedIn. We'll start in a sec. Let me know if there's any questions if you have tried bodychaos.com. You can provide your feedback real time. Pop this in the chat as well. Please provide your feedback. Right. If there is just by chance, if there is no feedback from human, we'll get some feedback from ChatGPT. Let's start a new chat. So we'll do 3.5 first, then move to 4. We have both open and running. We have GitHub Copilot running in the code. So finished this one earlier this week. It's a pretty basic, a real EEG. Sorry for the ads. A real EEG, you can select your channels. This 16 channel EEG recording, intracranial with seizures. You can scroll through the file. You can select your window size. The selector here, yeah, this is not great. Don't like those controls. They're not fun at all. In info, let's say make not to use what it is called. Oops. Control Shift C. Spin button. Yeah, those spin buttons. Make sure to use spin buttons only if absolutely necessary. Right, this undecimated thing is actually right, so okay, let's do it step by step so we're not getting all over the shop. Right, so this is the tool that is working. Now we're doing a similar one that looks more like this. The main difference is that it also have a wavelet denoise options. Now we already have some so it's going to be a Flask application. That's so I can share it with you. We can play around with it. Provide your feedback. Now the problem is the problem is just start with 3.5. Well, there's quite a lot of problems, but mainly I wish there was a way to move from 3.5 to 4 in a more seamless way, so we don't get to the 50 messages every three hours prompt limit. What we can do though is let the GPT do its thing. Well, mainly because it's running faster, just so it gives us more ideas regards how we can improve the code. So this will give us a description.
The JavaScript code you've provided is an event listener that executes when the DOM content is loaded. It sets up various event listeners for different elements in your web page and fetches and renders EEG data based on user interactions.
Right, that's right.
Here's a breakdown of what the code does.
No, we don't need the breakdown for now. Now this is the actual Flask application. It does its thing. Now we also have the styles CSS, but we'll deal with it later. Okay, let's do those. See what it suggests.
Wavelet denoising is a technique used to reduce noise in signals while preserving important features. Its effectiveness depends on several factors, including the choice of wavelet, the level of denoising, and the characteristics of the signal and noise. If the effect of denoising is not very clear in your EEG data visualization, here are some possible reasons and suggestions for improving it.
Right, well, that's actually interesting. Let's see what it says.
Wavelet selection. The choice of wavelet can significantly impact denoising effectiveness. Different wavelets are suitable for different types of signals and noise. Experiment with different wavelets to find one that works better for your EEG data.
We have a wavelet selection option, the wavelet type selection. Now with GPT-4, that's the one that I actually expect to generate better code. Might start populating it slowly, but surely. Yeah, it's also getting a breakdown. So we can already have that wavelet selection.
Denoising level. The level of denoising, thresholding, is another critical parameter. Adjust the threshold level or multiplier in your denoising code to find the optimal balance between noise reduction and signal preservation. You may need to fine-tune this parameter.
That's an interesting one. We might edit as well. What else we got?
Signal to noise ratio, SNR. The effectiveness of denoising depends on the SNR of your EEG data. If the noise level is very high relative to the signal, denoising may not yield satisfactory results. You can try to acquire cleaner EEG data or apply additional noise reduction techniques before denoising.
So this EEG is probably the cleanest signal you could possibly get, because it's being recorded directly from the surface of the brain. It's coming from an implant. The other unique thing about it is that it has epileptic seizures in it. So we actually try to optimize for those. Why is my trying to... Yeah, my mouth is barely moving. It's not very great, is it? Yeah, we don't have the playback feature at the moment. One thing I noticed if GPT-4 or 3 or whatever actually needed to run for longer for it to do something useful, as in clicking the stop generating button can yield all sorts of weird results, mainly to the fact that it's losing context. Lazy loading of data, what's that? Let's ask it the same question we did GPT 3.5. See and compare the results. This is back to 3.5. What else is it suggesting?
Visualize denoising. To assess the impact of denoising more clearly, consider creating separate visualizations that compare the raw EEG signal with the denoised signal. This can help you visualize the noise reduction more effectively.
This is not a bad suggestion. So we could, it's actually a pretty good suggestion. So let's load a Flask application and see actually what it looks like at the moment. Right, so this is what we have. And yes, considering yeah, we could just plot both of them. Another option would be to have options for both displays. So have, say, red and blue. Well, then the problem would be, how do you do those in different colors? I guess we could do another tool later that just has the time domain. Where it's comparing side by side the noise than the original signal.
Evaluate signal quality. Before and after denoising, evaluate the quality of the EEG signal. Check if any important features or details have been lost during denoising. It's important to strike a balance between noise reduction and preserving meaningful signal components.
Yeah, these values are currently not displaying anything. Make sure signal noise and mean square error are showing values. Okay, let's move to GPT-4. So we have that. It's the same wavelet selection. Decomposition levels.
Decomposition levels. The level of decomposition can play a significant role. A high level of decomposition might capture more of the noise, but could also remove some of the original signal. You may want to experiment with different levels to see which gives the optimal balance between noise removal and signal preservation.
Okay, so that's pretty much similar to what GPT 3.5 said. 3.5 surprisingly doesn't have a thresholding section.
Thresholding. The thresholding technique and the threshold value can significantly impact the denoising result. The thresholding you're using, multiplier *NB, SQRT, 2 *NB.log, len, eg_data, is a common one based on the universal threshold. However, there are other thresholding methods, such as soft and hard thresholding, and you can adjust the multiplier to change the threshold value.
Yeah, probably want the original to be grayed out in the background. Um, make the original EG signal and the denoised time domain. If the noise is on, the original EG signal is displayed is grayed out, and the denoised signal is in color. Make value denoise on by default. Okay, let's do step by step. How to change the code so that this should be simple. Let's start with a simple task. But we'll change the HTML.
In your JavaScript code, inside the DOM content loaded event listener, you can set the check property of the wavelet denies checkbox to true.
HTML there's no default option selected, which is unusual. Okay, so we changed it in the JavaScript. It should be fine.
Adjust the default value for the wavelet denies parameter in the get_data function to true.
So those are different options, is it? Yeah, I can just use the just modify the front end, the JavaScript. Check it. Yes, so wavelet is on by default. Now, next thing, yeah, make the original EEG signal and the denoised EEG signal in the time domain. Make sure if the noise is on, the original EEG signal is grayed out and the denoised EEG signal is in color. So let's do this next. So we need to do two things. One is
modify the backend to always send both the original and denoised EEG signals. Modify the front end to display both signals and adjust their appearances based on the denoised checkbox state.
right. So in the backend, in the Python code, in get data, prepare the data based on the original and the noise signal. Right, so we have a response data. Okay, so there's quite a few changes. Let's create a copy of Python script just in case we stuff something up. Can it generate the whole generate the whole we should say regenerate the complete get that root function. Okay, let's see. So we have start second, window size, that's the same. Calculate the indices using define the sampling rate, that's the same. Extract the segment from the full data set. Channel, yep, that's all the same. True log. Wavelet denoise. Oh, by the way, not using frequency scale yet, even though pretty sure it's working okay. Yeah, I want to check linear. Yes, it's, I don't know what it's talking about. It's a linting program. Seems to work okay. Levels, the same. Validate waveforms. Okay, we have some changes there. Yeah, we don't actually need to do this, do we? JSON file, original EG data, did train. Okay, let's move it. Let's move it along quicker, otherwise we'll never get anywhere. just checking that it didn't miss anything major. And it's sending with return JSON file. So we can replace this whole thing. Yes. We need to modify anything else.
This regenerated function takes into account the default ON state for wavelet denoising, and always sends back both the original and denoised EEG signals. The original EEG signal will be grayed out if wavelet denoising is on, and the denoised EEG signal will be in color, blue. If wavelet denoising is off, the original EEG signal will be in color and the denoised signal will be grayed out.
Okay, that didn't work. Don't get any errors in the terminal. Let's reload. Type error cannot read. Properties. You know what I'm using? Okay, so the Python code returning response data. Let's check that. Plotly, new plot. Just call data. Boo, 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 boo. Response JSON. Okay, what's going on? Give me generic stuff. They regenerate this response. I don't like it. What? No. It's like it was working a second ago, right? So let's check the error again. Do I need to update JavaScript? Seem to be more specific
To
response.
fully integrate the changes made to the back-end code, you might need to update the JavaScript, JS code, especially if you're using any front-end library or framework to display the data. Here's what you need to consider. Handling multiple EEG lines, the updated back-end now returns two signals, original underscore signal and denoised underscore signal. You need to ensure that your JS code can handle and display both signals on the same plot.
Currently don't have an update plot function. Okay, can you do the whole thing? How to update this JS? Because I wouldn't know how to do it. That's what I have you here for. Seem to be specific
Given the new
advice.
changes in your Python backend, where both the original EEG signal and the denoised EEG signal are sent, you need to update your JavaScript to reflect those changes.
Yep, we need to plot both signals.
Plot both signals, update the fetch data and render function to plot both the original and denoised EEG signals.
That makes sense.
Set default for wavelet denoising. You have already set the default check state for wavelet denoise to true. Handle visualization color. You'll make use of the line property sent by the backend to color the signals accordingly.
So this one has yet two signals. Wait, how is it different from what we already have? Why do we have new plot? It was... Doesn't make sense. Signal X, signal Y, signal name. So this should be two signals in there. So that's the raw EG. Wait, where is the... Where's the original? This should be original and the newest.
This modification uses the map function to transform the raw underscore signals array from the backend into the format required for plotting with Plotly. It then passes this transformed data to the Plotly new plot function to render both the original and denoised EEG signals.
Right, so they're both included. Rest of the plotting code. I don't have anything. Ah, this meant with the frequency domain. So that would remain the same, at least for now. Yeah, let's check. Right, check this out. Looks like the our one is not. Ah, no, it is the trended as well. Wait. Right, so this showing both. Let's reduce. Doesn't make much difference, does it? And I'm not sure why they're not exactly overlaid. Where's the trend? Yeah, one. Okay, the trend should apply to both of them. Yeah, you can barely. Right, so that's what it does. This filter order is for the frequency spectrum. Shall we change the levels? This kind of indicates what the trending does. The problem that the frequency spectrum is essentially displaying the same on Earth. Just changing the colors. What? Yeah, that wavelet noise is playing up. It's probably better to be removed. Might want to add more levels just to check what difference does it make. Let's make it 5 and max 10. Yeah, this the trending makes them overlaid. Yeah, this is the effect of the levels. Now the problem is, as you can imagine, yeah, that during seizures is behaving not quite the same. It's not quite clear what's happening with the colors when you switch wavelet denoise off. I understand when it's on, it's fairly clear what it does. Now the original is also before the trending, and the blue one is detrended and wavelet denoised. That's why you see offset, a DC offset. Yeah, so this can be a bit misleading in a sense that yeah, you can only see the denoising working well when making the window size smaller, and you can actually see the difference. And it's not working well during seizure. Yeah, so this is what it actually does, just kind of smoothing the signal in different ways. Yeah, this is the epicenter of the seizure. Sorry, not the epicenter. You know what I mean? Epicenter. Yeah. This is where the seizure is happening. Yeah, but it's hard to see. What's going on with the denoising. Yeah, it's not too bad. Yeah, but don't particularly like those buttons. Let's see what it says if we yeah, those spin buttons.
Alright, let's streamline the JavaScript code to make sure unnecessary operations are avoided, especially with regards to spin button or any other interactions.
No, that's not what I meant. Can we replace spin buttons? It's these little annoying things. Drop menus are not great, but okay. But those are horrible. Can spin buttons be replaced?
Certainly. The type of control you're referring to, often known as a spin button, is commonly implemented using the HTML less than input greater than element with type equals number. The exact nature of the replacement you're interested in depends on your specific needs.
Yes, sliders are better. So in HTML, yeah, I don't like drop downs. Text, no. Custom, well, no. Can we try sliders? The slider control instead of spin button. Yeah, window size. Okay, window size input. Yeah, this one. So replacing it with a type range. It's the same ID. So this should just this works. Why the label? Is behind. Right, this one.
Update the event listener to display the current value of the slider in the label.
Window size. Is it just called input? No. Window size label. We're doing. So it should update that number there when you're changing the window size. It's going up to 100. Yeah, it's all messed up a bit. Yeah, wanna display whole spectrum, should we turn it on by default? The trending is moving the signal around 0. This is working okay. The number of levels is really only visible when you turn the trending off. Select, say, this one. Yeah, this channel. Should be a 1 second. Okay. Yes, that's what the levels are doing. Yeah, refresh the page. That's the default view. Yeah, channel 7 is default. That wavelet is default. Yeah, I'm not sure. That's some sort of bug when you deselect this. I'm not sure what's happening with the colors. Would expect it to do something else. That's how the training work. This filter order is actually only affects the frequency domain. It's not clear from here. Yeah, you can choose to show the whole spectrum. Those 3 components should be at the bottom. So should rearrange the page. Should have channel number, window size, sub. Can we do something crazy? We tried this before, but it didn't really work. If we go print screen, just select the bloody thing, and we pop it into ChatGPT to how to improve front end. So it will pop this in. It will think for some time. Let's see what it says.
The provided front-end design seems to be quite functional for the visualization of EEG data, but there's always room for improvements, both aesthetically and in terms of user experience.
Yeah, that's right.
Here are some suggestions.
Yeah, we have a color, a theme. And actually, the thing about this style CSS is that we have this standard styling for our pages. So we have like a global CSS file and a local one. So in the local one, the CSS should be only applied to the specific components on this page. Everything else like text, background, things like that will be taken care by the global CSS file. So we'll have 2 of them. Yeah, so that's the global one. and a local one in a static folder for this specific web application. So this is a bit painful to debug because it will look different. When in production. So yeah, so the color palette, consistent spacing, typography, so key interactive elements, legend, graph, improvement, mobile, responsiveness. Yeah, we'll have to sort it out later. Instructions, there are some instructions in the bottom. This one.
If you're implementing sliders as discussed previously, ensure they're styled consistently with the rest of the interface. Display the current value prominently.
Display the current, yeah, we want to display the current value. Yeah, we also want to change the layout. Should we do it first, or should we have all the controls in one place? Let me know what you think. So in essence, because generally speaking, these three, there will be more, are related to the wavelet transform that reduces noise. Then we have the overall things like the channel selector and the window size. Affecting the whole thing. Yeah, this one is not, the trending is not affecting the frequency spectrum, which makes sense. No, it does a bit. This filter order is only affecting the spectrum. So it's how sharp the bandpass filters are in the spectrum domain. Whole spectrum is affecting the spectrum, is adding that extra line. Frequency scale is obviously also only affecting the frequency spectrum. So in theory, all this from filter order. Okay, let's sort it out. A filter order. Whole spectrum and frequency scale should appear next to each other, and frequency spectrum chart. Yeah, we have to out below or something. Yeah, on different screens it will appear differently. I kind of don't really want to spend too much time on it. Yeah, it would be easier just to have all the inputs in one place, but then it kind of doesn't make sense. Again, because this filter order only affects the frequency spectrum. I'd also like to remove, so we change the window size. Can we use Copilot for that? Copilot is just not do anything whatsoever. Well, nothing useful, at least. All spectrum, where was it? Filter. Yeah, I want to change. Let's say make sure the original signal. Alt. All spin buttons be replaced by sliders. Okay, CSS, HTML. So we have control group. That doesn't make sense. Grouping and layout.
Group, filter order, whole spectrum, and frequency scale controls horizontally. You can achieve this using CSS flexbox or grid layout techniques. Position these controls directly above the frequency spectrum chart to ensure they're easily associated with the chart. Style each control to be of similar height and maintain consistent margins between them. This will present a more cohesive look. Consider adding light borders or subtle shadow effects to each control to provide a hint of depth.
We don't want a hint of depth for sure. Don't like it.
If feasible, make the frequency spectrum chart update in real time or with a slight delay as these controls are modified. This gives instant feedback to users about the changes they're making.
That's already working fine.
Clearly label each control. If space becomes an issue, consider tooltips or drop-down hints. As the screen size changes, especially decreases, these controls should stack vertically above the chart. This ensures a good experience across all device sizes.
Right, let me change the so we're changing window size input with a slider. We did it in the HTML. Now we forgot to do this in JavaScript.
Update the event listener to display the current value of the slider in the label.
Window size label. Size label. This one goes window size. This can go there, and in the event listener section, a window size input. Can add this. Let's see what it does. Right, so it's changing that. Yeah, now it's a bit pretty sure we want this to be change. Right, this is better. Okay, now we want to do this. This can be displayed on top. So in CSS, quick break. Be back in a sec. Okay, back. Doing our sound check. Can't hear anything. Why? Right, that sounds okay. Okay, let's finish this. So we're changing the spin buttons because we don't like them.
Yes, spin buttons, often rendered as input fields with up and down arrows for numerical values, can be replaced by sliders. Sliders are typically more visually intuitive for selecting a range of values and can improve user experience, especially on touch devices.
HTML.
Replace the input type from number, spin button, to range, slider.
This number. How many of those? Do we have? We have two. Filter. Should be filter order and levels. Just replace them by range. And now come the window size. So we should have we get rid of play. Oops. Right. So how many ranges? 4. How come? Levels. Window size. Filter order. Ah, and of course, yeah, the file scroll. Now, levels, the label goes first. Right, size. Right, that's working. Okay. Right, so that's HTML. Installing.
You can style sliders using CSS to match your design. Here's a basic example for styling.
Leave styling for now.
To capture the value from the slider, you can use JavaScript event listeners, similar to how you'd capture values from spin buttons.
Okay. this wavelet noises checkbox. And checkbox is replaced by buttons. Again, check boxes be replaced. Let's see if it gives us some options. Toggle switch. So I want a toggle switch or a button. So in here, toggle. Doesn't work, does it? Yeah, it would be nice to have icons in there. Okay, so replace the noise with a toggle switch. Uh, that won't work, would it? JavaScript. Channel select filter. How to replace this in more specific. Start to toggle switch. Is this all for the switch on? Yeah, I'll change the colors in a sec. In JavaScript,
If you were using the original checkbox, wavelet denoise, in your JavaScript code, you need to replace any references to it with the new wavelet denoise ID. For instance,
yeah, we have a different name now. And to replace
now, with these changes, the original checkbox for wavelet denoise will be replaced by a visually appealing toggle switch, while retaining the same underlying functionality.
can we still use that? And set default to on. Not bad at all. Then go first, is it? Right, can remove that. There's an error, of course. Right, that's actually, it does work in the same way. A JavaScript 120 This can't be. It's called the noise toggle now. Right. It's not doing anything. Why? It's not giving any errors. Anything else seem to work? Oh, that's okay. It's a nice little button, but it doesn't stop working. Yeah, we should know. I have no mention of where the noise. We changed it to toggle. Can get rid of that. Change. This is not doing much. Why? We still have. Yeah. It's not changing the trend. True filter, whole spectrum. This is not in a get request. Right, this should be changed to toggle. Could have just remained the same thing. Right. And in HTML, okay, this is not a checkbox. Should be passed in the GET request. Everything was it was changing the colors. Right. That number should be in span. And wavelet noise in get data. We might not need that. Doesn't look like it's passing in the get request like everything else. Okay, let's do this quickly. Let's actually try GPT-3 for that. I'm probably gonna hit the limit pretty soon, the 50 messages per 3 hours. Yeah. So we'll do let's say, oops, this is for reference only. Read the code and do not confirm reading the code and don't generate anything else. This will be pretty amazing. I suspect it confirmed I read the code. That's pretty amazing. It actually works. Confirmed. That was the HD. Is the HTML? That was the JavaScript. We added the HTML prior, and we have the Python code. Confirm reading, don't generate anything else. Same here. And now wavelet denoise button. It doesn't work. No, what is it called? Slider? A toggle switch. Let's see what it says.
The provided CSS contains styling for a toggle switch class with a slider, but there isn't any JavaScript provided to handle the behavior of the switch.
Why not?
For the wavelet denoise toggle switch to work, you typically need
HTML. We have the HTML element. Yeah. Yep.
JavaScript
JavaScript.
to handle the toggle action, e.g.
Okay. I'm pretty sure we have something. The noise.
Then, integrate the toggle state into your Flask app request when getting data.
Okay. Yeah, that's what we had before. Anyway, so that should be fine.
However, from the Flask code you shared, it seems that wavelet denoise parameter is already expected in the request. Therefore, ensure the toggle switch in your front end correctly sets this parameter when making a request to server. Check if the HTML and JavaScript for the toggle switch is properly set up. Ensure that the state of the switch, on, off, correctly modifies the request sent to the Flask server. Make sure the Flask server correctly processes the wavelet denoise parameter and applies or doesn't apply the denoising accordingly.
Okay, can you do this for me? See above. Is this specific stuff or generic? You have the code. You have the code above. Okay, that's getting annoying. Is the problem with the name or something? Come on, are you joking me? I just gave you the code. It's getting a bit funny. Okay, so I have this and that. in JS, then in HTML, in HTML, this, and in Python. I think it's the order of things. In Flask, this. Okay, so we need to consider.
Ensure that the JavaScript code that initializes the checkbox and sets the event listener runs after the HTML is fully loaded. You can achieve this by placing your JS code at the end of the HTML body or using a DOM content loaded event.
Yeah, we have the downloaded event. That should be fine.
Ensure that the fetch data and render function is correctly defined and doesn't contain any errors that might prevent the listener from being executed.
This one. Yeah, we're not using playback at the moment. All that function can go. Right. We have the element by this section. We have a wavelet denoise there. Okay, in fetch, in const parameters, it wavelet denoise as well. Right, now it's working. Po, 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 po. Okay, I think we can done for today. We did quite a bit of progress. Yeah, I wanna later change the detrend button also into I always forget what's called. Switch. should we do it now? Do we have some time? Probably not, but we'll do it anyway. What? Ah, it's actually working if you click on the text as well. That's handy. Yeah, we need to break down the inputs into different parts. Will be 3 parts. Inputs should be broken into 3 parts. File wavelet and spectrum. That's right. Smart boy or girl. Filter order. Roll channel number. Window size. Be on top of the page. A filter order whole spectrum frequency scale should be next to each other. Should be next to frequency spectrum chart. Then you have trend. Wavelet noise. Does this have a label? It should have a label. Ah, this to give errors. I forgot about it. Yeah, we'll continue this next time. Let me know if there's any questions, please. Let me know if you had a chance to review the site. And this new tool will soon appear on it as well for you to play with. To look, that's the previous one, just a simple scroll through the data. And currently, and this one will be essentially an advanced version of it. So hopefully we'll finish it next time. Don't forget to, you know what to do on YouTube. Subscribe, like, comment, tickle the YouTube algorithm.